Good morning to all, and now we are going to see about digital logic microprocessor second module. So that is combinational circuits. In combinational circuits we are going to discuss about the topic that is encoders. So what is meant by encoders? So that is encoders. So encoders convert, that is 2 power n lines of input into codes of n in n bits, and decoders, that is decode the n bits into 2 power n lines. So it can be purpose of transmission and receiving of the data. So while transmission of the data, that is there is more number of inputs, so there is 2 power n lines of input, that is that may be different voice and different voice signals and data transmissions and different modes of transmissions, that can be 2 power n lines. So there is a many number of inputs that can be coded, so that can be coded into n bits and transformed into the transformed by means of encoders. And then the purpose of decoder, so that is the decode the n bits into 2 power n lines. So again the decoder, what is the function of decoder means the n bits that is received from the output of the encoder, that can be converted into the 2 power n lines. So 2 power n lines means the transmission can be sent, that can be received as the output. So by means of there is due to transmission losses, we can performing using the encoders to preventing that losses in the transmission. We can encoding the signals in the transmission side and also decoding the signals in the receiving sides. Encoders, so this is the combinational circuit that can convert binary informations in the form of 2 power n input lines into n output lines, which represents n bit for the input. And for simple encoders, it can be assumed that only one line is activated at the time. Only one line is activated at the time. For example, let us consider octal to binary encoder. So octal to binary encoder and octal to binary encoder, that is 8 input lines that can be separate 3 output lines. So by encoder, that is a 2 power n input means that is if we are giving n value is 3, means that that is 8 input lines that can be converted into the 3 output lines. So that is 3, and that is n value is 2 means that is 4 input lines that can be converted into the 2 output lines in the encoder. Likewise, we are performing different operations, and for value of the n is 4, we can performing the 16 inputs, and that is and receiving the 4 outputs. So likewise that is performing the encoders. Next one, that is the 8x3 encoder circuit diagram. So in 8x3 encoder, that is we are giving input, that is 8 inputs are given, and output, that is 3 outputs is receiving. So for example, that is what are the inputs means, that is D0, D1, D2, D3, D4, D5, D6, D7. So these are the different inputs we are giving to the encoder, and by giving these inputs X, Y, Z, so that is the 3 outputs we are receiving. And this is the truth table for encoder. So for values, all the values are 0, that is X, Y, Z also 0, and the values, that is D1, so only one input is 1, we are getting the output through Z, and also we are getting the input from D2, so we are giving the input to D2 1, and we are receiving the output in Y. Likewise that is we are giving input in D7, so that is D7 is 1, we are getting the output from all X, Y, Z as 1. So based on the input given the data D7 to D0, the output performance X, Y, Z can be obtained. and this is the Boolean expression. After plotting the K map, the Boolean expression should be x equal to, we are obtaining d4 plus d5 plus d6 plus d7. So which means the wherever the x values are 1 in the truth table, wherever the x values are 1, in similar way that can be d values can be measured. For example, that is d4. So d4 is 1 for x value, and also d5 is 1 and d6 is 1 and d7 is 1. So these are all the x representations, so we can adding that values. So that is wherever the x values is 1, the corresponding d values can be measured. So the corresponding d values wherever that is 1, that can be written. Likewise that is y value, that is wherever that is y, that is in y value, that is d2 and d3 and d6 and d7, and similarly z value, that is d1 and d3, d5 and d7. So these are all the output values. So by using these operations, the Boolean functions can be written as x equal to d4 plus d5 plus d6 plus d7, and y equal to d2 plus d3 plus d6 plus d7, and z equal to d1 plus d3 plus d5 plus d7. So these are the Boolean expressions in the written form. And this is the logic diagram. We can using OR gate operations for different inputs, performing the circuit diagram. So this is a form of the circuit diagram. And priority encoder. So what is the priority encoder means? There is we are giving more inputs, more number of inputs, that is 1, the priority will be taking place. So that is known as the priority encoder. So priority encoder is the encoder circuit in which inputs are given priorities when more than one inputs are active at the same time. The input with higher priority take precedence and output corresponding to that is generated. For example, that is a d value, that is all are 0, and xy, that is xx 0, and similarly that is last one, that is 1, and remaining is don't care. So wherever the one which is first come once, so that is taking as the higher priority, and remaining values, that is not considering the remaining values. So remaining values, that is not considered, and it can be taken as the don't care value. And next one, there is decoder. A decoder does the opposite job of the encoder. So that is it is a combinational circuit. It converts n lines of the input into 2n. So that is the output of the encoder can be converted again into that can be given into the input of the decoder, and it gives the output which is same as the input of the encoder. And this is the example for a 3 to 8 line decoder truth table. So for example, that is here that is opposite of the encoder, we are giving 3 input and we are getting the 8 output. And for example, that is we are 4 input, means that we are obtaining 16 output. Like that, that is opposite to the encoder. So here the value of x, y, z, that is 0, 0, 0, means that is only output, d not is output, and x, y, z, 0, 0, 1 means that is z value is alone 1, means the output is given as d1, and the y value is alone 1, means the output is obtained from the d2. Likewise, all the values, that is x, y, z is 1, means we are getting the output from d7. So this is the implementation of the decoders, that is d naught equal to x bar, y bar, z bar, and like the d1 equal to x bar, y bar, z. So this means wherever the values are 0, so d1, that is d naught equal to 1, the x, y, z, all the values are 0. So that means x complement, y complement, and z complement. Where the d1 equal to 1, z only values, and the x values and y values can be obtained as complemented values. So we can write as x bar, y bar, and z. So likewise, we are writing all the values d1 equal to x bar y bar z, d2 equal to x bar y z bar, d3 equal to x bar y z, d4 equal to x y bar z bar, d5 equal to x y bar z, d6 equal to x y z bar, d7 equal to x y z. So this is the logical diagram for the decoder. We are giving x y z as the input, and the output can be obtained by using the AND gate. So performing the operations, so the x bar y bar z bar, so it can be written by using the NOT gate. So by using NOT gates, we are using the expressed equations as x bar, y bar and z bar. So this is the equation for logical diagram for decoder. So we are giving the 3 input x, y, z and obtaining the output as d1 to d7. So that is obtaining the 8 output, so which is opposite to the encoder. Thank you.